With the advances of AI agents, you no longer need to write and flash the code manually. Now watch what happens when I just ask an AI, turn on the single RGB addressable LED on pin 38 to switch colors one by one in 1 second interval. Within seconds, the code is built and flashed on your ESP board, and output is also visible. That is the power of ESP Claw, which is an Espressif's take on popular OpenClaw AI agent framework. ESP Claw doesn't need any IDE to flash the firmware. You just need a Chromium-based browser such as Chrome or Edge. Today, we learn how to simply chat and run a code on our ESP32 board. So with this ESP Claw, you just need to type your query. For example, you want LED to be turned on and off for 5 seconds interval. You can simply type and it creates a Lua code live on ESP32 with the help of LLM that you will be providing. Second is event-driven architecture. ESP Claw can react to your messages. So all the memory will be stored inside your ESP32. This ESP Claw makes your ESP32 device as MCP client as well as MCP server. You can use 3-tier event handling. For example, you get an event, you first write basic rules which are local, and based on that it will decide. And if it cannot be decided by local, it uses LLM reasoning, so that is tier 2. And then if there is a complex inference like images, etc., it can also send to the cloud, that is tier 3. So as I said, there is no need of any other toolchain or IDEs like Arduino IDE. You just need espclaw.com. If you are getting in Chinese, you can simply click here to modify into English. So first you need to connect your ESP32 S3 to USB, and then you need to click on connect. So you will see this. So when you connect, you will be seeing two different firmwares. For me, this has worked. You need to provide your Wi-Fi SSID and password so that it connects to the internet. So for this LLM service, I'm not using any of these cloud platforms because I don't have the paid subscription for using the APIs. So I'll use OpenAI compatible API and try to download Ollama. You can simply download this Ollama. So once you download, Ollama will be loaded like this. And here you can see various models that are available. So on the top, you can see the cloud models. So after this, you also need to modify a few things in the settings. So make sure you connect to your account, and then you need to click on this expose Ollama to the network, and also make sure you enable this cloud toggle button. Ollama supports this OpenAI compatible API. I'll simply use this one, and in the API base I'll have to use this. So this is the IP address of your laptop, and the port is 11434, which is exposed by Ollama, and version 1 you need to provide here. And the Llama model you need to use is Gemma 431B Cloud. So this has worked properly for me. And second thing is API key. Because it is mandatory, you can simply write Ollama here. And then you need some messaging platforms like Telegram. So we click on Telegram. So to get the Telegram bot token, first you need to search for bot father in Telegram, and then use this new bot so that it will create a new bot, give it a name, and also you need to give a username that is ending with bot. And in the below I can find token. So I'll copy just that token. You also need to provide a search engine. Click on this, open Tavily dashboard. You just have to register. You simply copy here and paste it here, and now click on flash firmware. So if it is not starting, you just have to click on boot button in your ESP board, and in the console you can see the flashing has been completed in 123 seconds. Disconnect here, open Arduino IDE and open serial monitor. So I'll simply select the board and port, dev module and this. So I'll get something like this. So it is trying to initialize everything. Start bot. It is saying ESP Claw is snapping on it, which means that your ESP Claw is ready to help you. So first we'll try to ask what is its status. You can see what is the uptime, what is the hardware, CPU utilization, RAM, network, and what is the signal strength. Next thing is we'll try to create a buzzer control. So I'll just say that I have connected active buzzer to the 12 GPIO. It has to make some music out of it using time duration, and don't stop until I say stop. So this is a bigger program, so it has to go through the different skills, so it will go through different rounds. So you can already listen to the rhythm that it has created. So you can see how fast it has created. It all depends on your LLM response as well. So while the buzzer is on, I'll simply ask it to again do another task, that is to make my single RGB addressable LED which is on GPIO pin 38 to blink in rainbow sequence of colors in half-second interval. Let's see how fast it can create. So now I can already see that it has already created the rainbow color sequence. And also you can see the buzzer is also coming. So which means that the buzzer and the LED program are two different programs that are simultaneously or parallelly running in different threads or tasks. So that is how cool with this AI agent framework. Now before proceeding, I'll simply ask it to stop this LED. So now it has stopped and come to a halt with a single color. So now let's go to event driven architecture and perform demo on that. So for this, I'll use a PIR motion sensor which is connected to GPIO 14 and monitor the motion and send an alert if you detect a motion. Let's see if it can do it without any glitch. So it is going through different rounds. Now I try to put my hand in front of the motion detector, but still I'm not getting the alerts. So sometimes there are some glitches because of the LLM as well as this ESP Claw, which is just in the early stage. So another important feature of this AI agents is MCP. So ESP Claw supports both MCP client as well as MCP server. So it can act as both. So I'll simply show you a quick demo on that. So in VS Code, I just logged into a Copilot to open the chat. You click on this customizations. So if you click on this plus icon, you will see these options. So we are using HTTP and then provide the MCP server. So you can provide the ESP Claw.local. So you need to press enter and the name you can provide ESP Claw MCP server and I'll put as global. So now you can see this MCP server is running. So I can simply ask what are the tools ESP Claw MCP server. So let's see if it identifies this MCP server and goes through it. So it has properly identified the tools. So once you have started and deployed the ESP Claw, you can simply type espclaw.local. It will open all the settings that you have provided. All these things can be seen here and can also be modified. I'll simply change here and provide Llama 3.23b. And now if you want to modify this and save, you can simply save changes and it will say it is saved and you can restart by using the reset button on your ESP32 to save this. And that's all for today. We have learned how to simply chat on Telegram and control an ESP board. This is just a glimpse of our future world. So stay tuned for more updates by subscribing to our channel and hitting the bell icon. If you found this video informative, please type helpful and smash that like button. Thank you for watching and I'll see you in another interesting video.